In this video, we are looking at angles in a circle. The properties are going to be described on this page, and it's going to come up with kind of a pattern that we can use as a rule for finding another angle when we're talking about angles in a circle. So, inscribed. Inscribed angles subtended by the same arc are equal. The words you don't have to worry too much about. I want you to be able to understand what I'm drawing. I'm not going to make you say the words inscribed, angles, subtended. That's very fancy. But what this is saying is that the angles are touching. Look, you can see that they're touching the circumference of the circle. So that's an inscribed, so it's in the circle, not outside of the circle, right? There are different rules when you're going outside, but inside the circle, subtended by the same arc. So arc, we know, is one of the curves around the outside of a circle. So this is saying that angles here that are touching the same arc. So when they're connected by the same arc, so these two angles here are connected by this arc, and what they're saying is that these two angles are going to be the same. These two angles here, these two corners, are touching that same arc, and that's going to make these two angles the same. So when I use dots, that's saying that they're the same angle. So that dot is saying that this angle and then this angle are the same. So that's indicating the same. And then if I use a different symbol, so say for instance this arc here like that, that's saying that these two are the same. So I'm going to say those two are the same. So this symbol here, the dot to dot, means that it's the same angle. The line to line means those two are the same. So that's what that means, is that same arc is that they're touching on the same arc. We're not talking about this arc. So you see here, this doesn't make sense because that's a straight line. We're talking corner to corner. So when we have a corner to a corner, those two corners are the same. Okay? And then here, corner to corner, those two corners are the same because they're touching on the same arc. I'll show you how to draw it at the end, and then we can go over them all one more time. But when you get a diagram like this, you know that these two corners are subtended by the same arc, so they're connected by the same arc here. So then that means that this one also is 40. So that's what they're saying by equal. So this one equals this. And these two here are also subtended, right? They're connected by the same arc. So then if this one is 25, this one will also be 25. So they're the same there. Okay. The next rule that we're going to look at is, it's called inscribed angles. So remember, inscribed just means in the circle. So in the circle, angles subtended by the semicircle, so not an arc, but by a semicircle, are 90 degrees. So how do we get a semicircle? A semicircle is only drawn if we went through the diameter. So it has to go through the diameter here. So here, that's the diameter. So diameter, I'm going to write some pen. Diameter, that would get you the semicircle. So anytime it's going through the center here, that's the diameter. Then anytime you draw an angle out to the circumference, this is going to be 90 degrees. So anywhere you draw it out, it'll be 90 degrees. So 90 degrees, 90 degrees. So as soon as it's touching the diameter and it goes out to the corner here, out to the circumference, then it's going to be 90 degrees. That one's a nicer one. Now, the next one, so there's 4 of these rules. So we want 4 rules. So far we have this one, subtended by the same arc, so same. And then here, 90 degrees when it goes through from the diameter. The next one is the measure of a sector angle is twice the measure of an inscribed, oh sorry, I have that written twice. An inscribed angle, that's my fault. It's twice the measure of an inscribed angle subtended by the same arc. So what that means is that if I have one that goes to the measure of a sector is twice the measure of an inscribed angle subtended by the same arc. So it should be, sector angle. So sector angle, sector means it goes to, this means goes to the center. So this one at the center is twice if I went here. So basically, we have to plant 2 feet here. So they're sharing the bottom. So think of this like you're sharing the bottom here. I drew one arc out, or 2 angles, or 2 lines out here to make an angle to the center, and I took the same 2 feet and I drew the same 2 out to the edge. When I draw it to the center, this is going to be, so say this is x, this would be 2x. This angle here is twice, so look, that's going to be twice as big as this one here. So not the same, but it's going to be twice as wide. You can even see it when we draw it. So for instance here, they're connected at the center. They both have the same feet. So what I mean by feet is that they're sharing this base here. Someone drew it out to the center and someone drew it out to the side. If you drew it to the side, that's 30. If you drew it to the center, this would be 60. So this would be 60 here. Right, so this arc here would be 60. So think of it like double. And it does look like it in the diagram as well. So if you look at it, you can see that this is definitely wider than this one. How much wider? Double. Okay, we're going to go over all the rules again at the end, but we're just going to go here. So next one here. In a cyclic quadrilateral, so if you're wondering why I gave you that definition, so in a cyclic quadrilateral, so you can see the quadrilateral is drawn to all the edges, or all to the circumference, the opposite angles are supplementary. Oh, I forgot to give that definition. Supplementary here means adds to 180. So we need to know the word supplementary. Adds to 180, so you do need to know that word. It will come back in some future mathematics. Supplementary means adds to 180. Opposite angles means this. So from here, so I've had A and a B. Those two are not equal, so they're not equal, but A plus B will add to 180 degrees. So same thing with the next one. So if I said these two, and we're not saying they're equal, so they say that's C and D, I know that C plus D would add to 180 degrees. So that's the rule. Now, that means that here, if I know that's 80, the opposite angle, if it adds to 180, how much would this leftover angle here be? So you go 180 minus 80, that would be 100. And you don't have to show this, right? I know we can do that on the calculator, so this would be 100 degrees. For here, if we know this is 60, then 180 minus 60 would get me 120, so this would be 120 degrees. So those are our rules. So those are our 4 rules. I'm going to go through them one more time. I just want to show it one more time. So if we have a circle, if we do a crisscross, so anywhere in the circle, not necessarily through the center, if we do a crisscross and we make lines here, this angle equals this angle, okay? And this angle equals this angle. That was the first rule that we did. So that's one rule. So 4 rules. So I'm going to say one rule, number 1. Another rule that we had, which is a nice little bit easier, the second rule was that if I go through the center and I make a diameter, anytime you draw an angle out to the edge, whenever you try to draw that out to the edge from the diameter, it'll always be 90. So that is my second rule. Right, so this is equal. They're going to be equal. And this is 90 degrees. The third rule, so remember there's 4 rules. So the third rule is that if I have a circle and I draw it to the center, I draw an angle to the center, and I use the same 2 feet here, and I draw it anywhere out to the side. So it doesn't have to be straight up. I can draw it anywhere out to the side, like this. I know that this angle here, so say that was 60, then this little angle here, that would be 30. So it's always half. So this is our half or double rule. Okay, it's half or double rule. Right, so we have an equal rule where they're equal, the 90 rule, and then a half or double rule. And then the 4th rule that we had was the cyclic quadrilateral. So there are 4 totally different rules. So we've got this one. So any cyclic quadrilateral, which means I draw any quadrilateral going corner to corner to corner, what we found was that they add to 180. So adds to 180, the opposite angles. So the opposite angles add to 180. So they're very, very different rules. This one is when you do a crisscross across, these two guys here are going to be equal, and these two here will be equal, right? So the corners on the same side. You can turn the page around. So sometimes you turn it around so you can see the rule a bit better. So you're always allowed to twist the page. But those are the 4 rules we have. Equal rule, the 90 rule, double rule or half rule, whichever way you're seeing it, and adds to 180.